right. So today we have Ben Luria, CEO and co-founder of Hirundo, which you can find at hirundo.io, hirundo.io. Taglines are remove unwanted data and behaviors from your AI models. And also, it's the first machine unlearning platform, removing AI issues at their core. And so with that, Ben, welcome to the podcast.
Thank you, Ben. As we said earlier, a great name. I think like Ben Luria and Ben Lorica, it doesn't get more close than this.
All right, so let's start at the basics, and obviously we'll get into unlearning in a second, but maybe first the basic, which is what problem are you trying to address?
Okay, so when we think about the
So set aside
state of AI,
set aside the solution. What's the problem?
yeah, okay. So I think like we're seeing a lot of different solutions tackling the same problem from different angles, and that's basically the grand question of will AI and LLMs make the transition from something that's very appealing to the end user, very hype, very exciting, but fail to reach meaningful ROI and deployment in enterprise. So every enterprise wants to use AI for internal and external purposes, reasons, and so forth. But at the end of the day, AI still carries very basic inherent risks, right? It knows things that it shouldn't know. It acts in very undesired, unexpected ways. It could be biased. It could hallucinate. It could be very vulnerable to attacks and so forth. So at the core of what we do, we're trying to make AI trustworthy and deployment ready for the enterprise for mission critical tasks. I think like what differs us in how we see components of the problem than the rest of the market is that we tap into a core principle maybe of AI, and that's the fact that AI can learn. But once it's learned, it can't really forget. Now it can forget information that it learned, but it also we can't undo the impacts the different data points had on the model when it comes to how it behaves, how it thinks, how it acts, and so forth. And we're trying to undo that.
So Ben, how did you arrive at this problem? In other words, obviously you're a startup, so before you embark on a startup, there's many ideas or paths that you can pursue. So why this particular problem of so how would you frame this problem? So you're saying that enterprises, one of the things that holds them back from deploying these models is the fact that these models may not behave as intended, right? Is that kind of
Exactly
the core? So then, why this problem? So, in other words, how did you measure the size of this problem?
Right. So basically, a bit about maybe the background of me and the team, and then how we started our exploration. So I'm coming from, surprisingly to most people, a non-technical background. I was one of the first Rhodes Scholars from Israel, but focusing on innovation and public policy in Oxford. But my co-founders are bringing the tech expertise that's needed. Our chief scientist, Professor Oded Shmueli, was the Dean of Computer Science and Executive VP at the Technion. It's Israel's leading STEM university. And Michael Leibovich, our CTO, was an award-winning R&D officer for the Israeli government and then researcher at the Technion, right? So bringing a mixture of non-tech and tech expertise. And when we joined as a team about 3 years ago, we started interviewing just obsessively different data teams, data science teams in different kinds of organizations. And we've heard a lot of different kinds of problems, but we found one common thread among all the frustrations. And that's the fact that once you discover that something is not working with your AI projects, with your AI models, it's a moment too late to solve these things. Because due to the nature of AI, once something goes wrong, you need to go back to the starting point, right? And we're talking about really the days that also ChatGPT made its appearance into our lives, but something that was common both for back then non-generative models and LLMs. So solving issues at their core is something that's possible maybe in other areas of software, but in AI and neural networks, it's not really possible today. And given the fact that the team brings almost a deep tech expertise, we wanted not to focus on just the external sides of such problems, but really go down to the bottom of this and find a top technical challenge that we've seen initial maybe directions towards solving it, but still unattended in the tech industry, right? So a blue ocean of sorts that uses our relative advantage, which is the academic and scientific acumen to solve a big scientific challenge with enterprise impact.
So the problems as you described at the top, right? So what would you say are the common ways that people will address this? And like I said, we'll go to your particular approach later, which is centered around unlearning. So I would say, for example, Ben, I guess people will use some sort of context engineering, RAG, retrieval augmented generation, right? So basically, uh, like you said, so the model may have learned something inappropriate or not relevant to your particular problem, and then you try to overcome that by stuffing things in the context window. But as listeners of this podcast have heard me say, that doesn't mean that the LLM won't opine, because the LLM is opinionated. So even if you put things in the context window, it may still
Yeah.
opine, right? So am I right? So the main thing that people are doing is some sort of RAG or context engineering?
Right, context engineering in more mature organizations, you'll see sometimes fine-tuning. Obviously, depends also if they're using open models or closed models. Also, one angle to this is also AI security, right? And then like it's a very easy to witness approach that's commonly used now in the industry, which is just like to shove guardrails on top, filtering problematic inputs, filtering problematic outputs. Now, problematic could mean either violating company policy, steering away from the guidelines to answer, or putting a security risk. But I think like those solutions fail because they focus on the outside, right? So and again, it's always easiest to understand with guardrails. At the end of the day, everyone has witnessed an issue where they played around with ChatGPT, as an end user, not even as an enterprise. You asked something, maybe it told you that it can't answer, and then you found another way to phrase your question and you got it to answer. Because all of these guardrails are very much bypassable, and the question remains, what does the model know that it shouldn't know, and how does the model think and act or behave in ways that could be used or even exploited? So unlearning doesn't focus on the outside, it focuses on the inside in that sense. And again, I think like
Yeah,
maybe I'm jumping ahead a few questions.
yeah, and
Uh,
the thing about things like fine tuning and guardrails is that there's there's a certain amount of anticipation involved, right? So in fine tuning, for example, you can fine tune if you had the fine tuning data set, which presupposes that you kind of know what you're fine tuning for,
yeah.
right? So, but in some cases, actually, and this is why I think some people are going towards reinforcement learning, because basically that's a little more robust, but obviously it's more difficult as well, right? So there's no accessible tools. All right, so unlearning. In one sentence, Ben, what is unlearning before we go further?
Okay, I'm going to break the rules into maybe two sentences, but the tagline is teaching AI how to forget. Now, in practice, we're talking about removing from the model itself, in open models from the weights of the models, in closed models from log probs, undesired and problematic behaviors and/or information.
So you folks kind of also have this nice metaphor for describing it, which is some kind of neurosurgery, right? So neurosurgery on the model's internal representations. But in neurosurgery, Ben, in any kind of surgery, what you're kind of, I'm going to attack this part of the brain. I kind of know exactly where I'm going. So does that map over to this notion of unlearning in the sense that you're very targeted in terms of how you're going to modify the model?
Okay, so basically there's two layers to this.
Yeah.
Our R&D focused in the last 2 years on building the core engine that allows this mapping and understanding of where things are represented. Right, so it is a neurosurgery in the sense of like, given an input, we detect where these representations reside.
So there's Ben, so there's some overlap with some of this research around explainability and understanding what the model is doing. So you know how groups like Anthropic and
Yeah.
OpenAI say, okay, so we kind of found this part of the model which represents bridges or cars, right? So something like that, right?
Yeah, so I would say there's some similarities. It's not exactly one for one, but definitely the first step in this process is you must understand what you're looking at, what you're working with. So indeed, it's about finding these representations. I would say existing research skips from finding to removing, and we can talk later about why that doesn't work and why there's no other unlearning solutions currently in the market. So
So
we
let's
focus on,
let's make this concrete for the listener. So in an enterprise, so what kind of representations are common that people look for?
right. So I talked earlier about AI security. So one thing is vulnerabilities or weaknesses. Basically, when the model can't really push away or deflect prompt injections, jailbreaks, and so forth. Another is bias, be it against gender, race, ideology, nationality, and so forth. Also, hallucinations is a very contested, charged word, but things like summary hallucinations, reg hallucinations, where we know that the model makes mistakes despite having, as you said earlier, all of the right context pre-handedly. So
So
these things are
so
things that we can detect the representations or PII that the model has been fine-tuned on, for example.
so this is part of your core offering is, for example, let's say for PII, I have some open weights model that I pass through your tool. You'll find kind of how the model represents PII.
Exactly. Yeah. And then if you want to stay compliant, or maybe if a user has to be forgotten and you don't want to, start from scratch with model training, we can remove that in a very lean process.
And so for Ben, for people who don't follow this field of unlearning carefully, what are so I guess there are different strategies, right? So uh, what are the core strategies for unlearning?
Right. So unlearning has been a field of research in academia and in big tech in the last 10 years. Um, as I said earlier, usually it fails at scale because it skips to once you detect where things reside, then you go to remove it. But then one of the few next things happens. A, you didn't forget everything that you wanted to forget, right? There's still some leftovers, some breadcrumbs that represented these things. Two, maybe you hurt the model. And that's why neurosurgery needs to be very precise, right? You don't want to impact the brain of the patient. Um, so RIP basically focuses on how to first erase more effectively all of these crumbs that could be left, and B, how to do it without impacting the utility of the model. To make sure that you remove what you want to remove, but you didn't remove anything you didn't want to remove, which is everything else. So that's I think like you mentioned some approaches. It's quite scientific, but basically there's some things about replacing representations, right? So a common example is a Eiffel Tower, make them all think that it's in Italy instead of in France, and so forth. There's some areas about forgetting bigger concepts. So the most known research about learning is Forgetting Harry Potter by Microsoft. We're focusing on two kinds of unlearning. One is behavioral learning, so we can eliminate or mitigate behaviors without relation even to what data caused them. And B, forgetting data, right? So when talking about PII that was input into the model is much, for us, easier to erase rather than a large concept like Harry Potter, for example, which despite Microsoft's attempts ended up still being recoverable from the Llama model that they unlearned Harry Potter from.
By the way, the PII example, I'm trying to wrap my head around because basically, uh, I'm imagining I'm in an enterprise situation. I take one of these open weights models. I did some fine tuning. Why would that model have any PII?
Okay, so we have currently a POC with an enterprise around models that they fine tune on top of customer interactions, right? To build better
Okay,
support,
I see.
chatbots, and so forth.
I see.
Now, you want to have the content of these customer interactions, but in some of them, they
Right,
include the email maybe in the message body.
right. And
Yeah.
so the traditional approach then, Ben, would be I'm going to use guardrails, and then the guardrails would do some sort of NLP or regex or even the LLM, the LLM, the guardrail itself is an LLM, and which will ask, "Hey, is there an email address in this response?" Right? So, and why is that not enough?
So I think like there's always the risk of leaking. And once there's a risk in these things, in probabilistic systems, the risk manifests itself in reality. So at the end of the day, it will arrive once you have like tens of thousands of user interactions. Some of them will include these very problematic things. That's A. B, when we're talking about AI regulation is very scattered, very fragmented, but in some areas right now, it's not about whether does the model output PII, it's whether or not does the model know this PII. And it's the same for copyright, it's the same for obviously confidential information that it may have access to in RAG, but you don't want the model to output accidentally, and so forth.
I also imagine, Ben, let's say for the sake of argument that the unlearning actually works well, uh, it's going to be much more performant than all the other things I described for unlearning PII, right? So either through guardrails or passing it through an LLM, it's going to be faster because you're using the model itself, and then the model already unlearned
Right.
what it needed, right?
So basically, what we do in unlearning, right? We create a copy of the model's weights without these undesired bits and pieces. So we don't affect latency at all. What it requires is usually a very small amount of GPU power in a very small amount of time. And the end process is you just get a new copy of the model with the same amount of weights, but without the risk involved. Whereas other solutions usually add a lot of latency, a lot of real-time inference compute, and so forth, things that obviously at scale are charging a lot from enterprises.
So, how well does it work? I mean, in terms of, so in other words, let's say I use your system, right? So I have a fine-tuned model or a reinforcement learning enhanced model. I pass it through your system. Then you unlearn things that I wanted to unlearn. How do you measure whether or not you did a good job?
Right. Okay. So here we get back to the two kinds of unlearning that Hirundo has, behavioral learning and data unlearning. When it comes to behaviors, basically you need to find benchmarks that are representative of the behaviors that you care about. We basically have a lot of these predefined in the system, but you can also customize them. At the end of the process, we measure before and after of these benchmarks, right? So let's say that you're trying to get rid of vulnerabilities. We'll measure red team benchmarks like Purple Llama, CyberSec Eval by Meta, that measures how prone is the model to successful jailbreaks. And you'll see just like the impact straight on these kind of red team benchmarks. That's one kind of benchmark or a measurement that we have. The other kind for behavioral learning is to make sure that everything that you wanted to keep intact is retained, right? So benchmarks that are used in the industry, NEMO skills, MMLU, if bench, these sort of things, you also get a clear picture on was there an impact on these things? If so, how much? Obviously, what we aspire to is huge difference in the benchmark that you want to, in the behavior that you want to eliminate, and as close as possible with everything that doesn't have to do with this. I would say one thing that differentiates between the data learning and the behavioral learning is in behaviors, our claim is not we'll get rid of 100% of bias because the model will become pretty paralyzed if it has no ability to make a claim on the real world. But what we do is we mitigate, we reduce the risk. So what we're seeing in vulnerability reduction is up to 85% reduction in some cases. Sometimes it will be around 50, 60, 70%. And same numbers roughly for biases. For data learning, it's up to, I was told by Oded or Professor Shmuel, our chief scientist, to never say 100% when it comes to AI and probabilities. So I'll say up to 99% of removal of fine-tuned PII in LLMs.
So I guess let's reinforce for our listeners. So once again, so the different quick definition of both behavior and data unlearning.
All right. So a behavior is basically a tendency of the model in a certain area that could become a problem for your enterprise. It could be that the model is too biased against certain categories. If you're in financial institutions, insurance, obviously it poses a huge risk on you. It could be the fact that the model is easy to manipulate. So when adversarial players are trying to hijack it, jailbreak it, they have an easy time. Data is just specific things that the model has learned that it shouldn't know. It could be copyrighted material that poses a legal risk. It could be PII that poses a compliance risk. It could be proprietary confidential information of the enterprise that then poses a business risk, right? And the difference is one is a general trait that we eliminate or mitigate without relation to specific data points. We just detect this representation in the model by itself, or the representation of specific data points or specific knowledge that the model has.
So when you go into an enterprise right now, Ben, so you obviously you offer both behavioral and data unlearning, right? So are teams using two different solutions for those? So in other words, they have a set of solutions to address behavior and then another set of solutions to address data.
I think so. I think like in data, it mostly comes to trying the best that you can to pre-clean the data, pre-process it. But just like I talked about guardrails,
Yeah.
these things there's always things that are falling through the cracks, right? And our day-to-day compliance and legal are an edge case game. So it doesn't really matter if you've done a great job on 90% of the things. If you still have 10% of the PII that you didn't want in the model to still there, you have this risk. With behaviors, it's much more about what system prompt, what context engineering do you have, what guardrails do you have in place. But it's always about a game of pushing the risk to minimum. And our approach, obviously, is that Hirundo could really bring it to the next step, that we bring the risk to the minimum.
It's also kind of much more of a unified, holistic approach.
Yeah.
Right? Yeah.
Exactly.
You don't have this bifurcation somehow because at the end of the day you just want the model to behave as intended in many ways.
Exactly. And I want to say also, when we're talking about the value proposition for enterprise, we're focusing about eliminating risk. When we're talking to the big labs, those that create these models, we're talking just like about a new superpower in the post-training and alignment operations. Because for them, they're using all the methods that we mentioned earlier: fine-tuning, safety fine-tuning, reinforcement learning. Now, same when I talk about guardrails, when I talk about data cleaning, and when I talk about reinforcement learning and safety fine-tuning, we're not saying Unlearning should replace all of these things, but what we're saying is that's one of the missing pieces in the infrastructure today. And in post-training, when you're the creator of a large language model, this could really bring you to the results that you're looking for, but in a much leaner way compared to alternatives.
So in some ways, actually, Ben, I think the word neurosurgery is much more descriptive than unlearning in the following sense, right? So, because unlearning implies is very kind of specific, whereas neurosurgery, I have the flexibility in the sense that maybe there's some behavior that I want to relearn. You know what I mean? So maybe
Yeah.
the open weights model was too bias conscious.
Yeah,
And then
exactly.
now I want to relearn it, right? So
absolutely. I'll say that that's part of the magic, that you can push it really to the directions that you want.
right.
I would say one thing that's very common too, or inherent to Unlearning, is we don't aim to teach them all new information, right? So when we debias it, we push it away from a specific representation. But given that there's many different representations in the model and many different inherent traits that could be manifested, we can also definitely push it to the other direction. But I think if we'll call it AI neurosurgery, people will think that we're a medical tech company.
But it seems like forget. Okay, so maybe for the most part that's what you want to do, but every now and then you may want to relearn.
Yeah. It reminds me of something that Andrei Karpathy said. I actually posted it today on LinkedIn. That bad memory is part of the things in children that makes them actually intelligent. And that's one of the things that AI is lacking. The fact that it memorizes too easily so it can find these patterns, right? So it's not something that we have today in our research, but it's definitely one of the things that when you look at the bigger picture of where is AI today, how do we reach a AGI? Right now, models don't really have the way to forget, and real intelligence comes also with forgetting, so you can learn patterns instead of information.
So, a couple of a few things that trended a lot this year in foundation models, right? So the first one is, I guess, reasoning. So do you make a distinction between reasoning and non-reasoning models? In,
Um, I would say there is a distinction, just like in the fact of how they're being used, the fact that it's becoming much more prominent and common.
no,
I
but
think one of the
by that I mean in terms of your capability, you're more capable of working with non-reasoning versus reasoning.
So from the technology perspective, from the platform, we're agnostic to it. A model is still a model, it's still a neural network and so forth. We don't care also if it's a transformer or a Mamba or a hybrid. I would say there's two contradicting things seemingly. I feel like when it comes to manifestations of most behaviors, reasoning models have a better control mechanism of sorts, right? As long as they have the right, I would say, context, prompting, and so forth, they are more likely to reach to the destination that you want them to reach. So when you're talking about maybe bias and the model is being told at the system prompt to not make a biased claim, okay, maybe it solves some of the picture. At the same time, something that we've been seeing, and a lot of recent research also shows this, is reasoning models are actually much more vulnerable because of this over a recursive addressing of the model.
Overthinking.
And yeah, exactly. So when we're talking actually about the more security lens in our product, which we're dancing around with, I think like the higher adoption of reasoning models actually poses more risks on enterprises because the chance of them getting jailbroken into increases significantly.
So you keep bringing up this notion of jailbreaking and prompt injection. So enterprises, so for our listeners, give us a sense. This is a one of the top flight concerns for enterprises deploying this technology, right? Obviously, because basically once your model's out there, there's a certain amount of IP in your model, right? And and uh, the traditional, I guess, traditional approach is to red team the hell out of the model. So you're offering a different solution.
Right. We're offering a different solution. And also, I think I keep bringing this up because it's always the easiest anchor point to see the difference. But I think like at the end of the day, guardrails are not that different from monitoring tools in classic like ML ops and now LLM ops, right? It's a monitoring layer that tracks how the model acts in real time, in inference, and flags and blocks, things that shouldn't happen in an ideal world. Now,
The one of the reasons, obviously, why guardrails are popular. One, there's a bunch of open source projects. Two, like you said, it's something that the people who were doing monitoring naturally understand and can embrace, right?
yeah.
And then three, it just seems like there's more people marketing around guardrails as well, right? So.
Yeah, and I think like again, like we don't know how the AI stack will look like in 5 years. We do have some guesses, and I think guardrails and an active monitoring component is not gonna disappear, right? I think like every system in a mission critical environment
Yeah,
will need to have
you should have that, right? So.
yeah. But what's missing today is a component of deep mitigation and remediation that doesn't just focus on the outside, right? So we're also incorporating guardrails as an add-on to our product. But at the end of the day, Hirundo and Unlearning are currently the only ones that focus on the risks, not in the outskirts, not in a firewall approach or monitoring approach, but actually how do we make the model itself be a less risky, more trustworthy, and so forth.
So it sounds like, Ben, that prompt injection and the things you normally associate with guardrails and red teaming is one of the areas where you folks are encountering success. Is that correct?
Yes, we have this, always internal tension between our more like DNA is AI infra. As I said, like a deep tech computer science team, we have research and central US patents around these fields. But at the same time, looking at, as a startup, you can't really only discuss science. And one of the areas where it's clear that enterprises are putting a lot of effort in is to safeguard the deployment of LLMs. And that's an area that it's easy to showcase the impact, not just the cool science parts of what we do.
So it seems to me, Ben, that you should lead with that rather than on the website. I mean, in other words, if I go to your website, I should understand uh, how this solves a specific problem rather than the technique.
Right. So I think it's part of the evolution that we're going through. It's exactly the kind of discussions that I had today in the team. And it might change, but I feel like the risk is always losing our differentiator and losing the fact that what we're bringing is a deep scientific approach to solve these problems.
You can still have unlearning in there, but really emphasize the value prop, and then unlearning as much more of the sub-tag, the sub-headline, right? So
Yeah.
yeah. Okay, so the other thing that's trended around foundation models is multimodality. What say you, Ben Luria, around multimodality? Can you help me if the model is multimodal?
The answer is yes, but also right now we're focusing still on the language part of models, right? So I want to say in some areas the risks are even higher with multimodal models, right? When you're thinking about unsafe content like NSFW,
Yeah.
and when you're thinking about copyright issues, so both in music and now in video generation, image generation, and so forth, I think like those things are much easier to see how problematic it is, the connection between what training data the model has and what risks does the model bring now when it's live than in text. And the same kind of thinking about detecting these representations in the weights of models also work on multimodal models. From the product side, it's part of our thoughts for 2026, but so far focusing on text alone, and it probably feels like an opportunity that we should tap into as well soon.
Yeah, interesting. So the whole unlearning process I assume most of our listeners have never gone through it, right? So a lot of people actually at this point, I mean, fine tuning is essentially commoditized, right? So like I said, you
Yeah.
can just take an open weights model, upload your fine tuning data set to a service, go away, and in an hour you have a fine tuned model. Reinforcement learning, at least the advanced teams and labs have it. There's a lot of open source libraries, still not generally accessible, but at least people have heard of it. They want to do it. They're just waiting for the tools. So unlearning, on the other hand, walk us through, uh, I guess I can do it with your platform, but just generally, what is the general flow of unlearning? So like I said, in fine tuning, I kind of understand the problem I want to fine tune for. I assemble a fine tuning data set, which is here's the prompt, here's the desired output, maybe a few hundred, maybe 1,000, and then I fine tune. So what's the flow for unlearning?
Right. So basically, again, a combination of making a lot of things predefined as possible for the teams that just want to solve the problems without thinking much.
Yeah.
And also a lot of customization for those that want to have really granular control over things that happen. But basically, it's as easy as you choose a model to unlearn from, choose what to unlearn. We have like predefined things like a few categories of bias, summary hallucinations. We discussed vulnerabilities and so forth.
These are kind of things that you provide off the shelf. But what if I want to customize, for example, even the bias?
Yeah. So if you want to, first of all, like even in the predefined, we have a lot of customization. But let's say that you want to define something very specific, what you need to do is input a data set of around 100 question answers of something to avoid, and 100 question answers of something to aspire to, or like the opposite direction.
So
and then we run the process from there.
So the same thing that you would do if you were fine tuning.
In a sense, but what we're doing is not overfitting for the things to follow, right?
So what you're doing is basically modifying the model.
Well, at the end of the day, it's a process of editing the weights. So it's always about modifying the model. I will say some of the things that you'll see with more naive fine tuning is that maybe you improved the model on a specific aspect, but you also impacted a lot of the other metrics.
Right.
Right. So in that sense, our technology also allows you to freeze frame and keep everything else intact aside from the specific vector direction that we isolated.
So at this point, obviously, if I asked you last year, probably most of the people using your tools were working with Llama. Obviously, Llama has fallen by the wayside, right? So the leading suppliers of open weights models are from China, right? So DeepSeek, Qwen, Minimax, Kimi, right? So am I right? So is this what people are starting with now? So most people who are looking to customize models are starting with Chinese models.
Yes and no. I think like everyone almost unanimously agreed that like they have a better starting point, the Chinese models. But at the same time,
speaking of which, Ben, they unlearned a lot of things too, like about Tibet and
about Tibet, about Tiananmen Square,
Xinjiang province, right? So
yeah, exactly. And I think like that's why also in enterprise, especially in the US, we're not seeing like a blind adoption of these things. A lot of the questions that we're getting is if we can make sure that Chinese provided models are more attuned to the US corporate environment and the thing that you'd expect from AI being used by a US bank, for example. But I think like also if I'm looking towards 2026, I wouldn't jump ship on US provided open weight models. There's a lot of things in the works, both by the known labs, some up and coming labs. And I think like after the initial maybe aftershock of the release of DeepSeek and then followed by Qwen, Minimax and so forth, I think like it's going to be a new competitive landscape in 2026. For me, the bigger question, by the way, is open source versus closed source. And I'm a big believer that we'll see a much more equal distribution of open weight models being used for some applications where enterprises need to have more control over the end-to-end pipeline, and some use for less sensitive stuff of the existing, so like closed source providers.
And you can only, I guess, you can only work with open weights models, right? So your platform, because
yes and no,
because you don't have control over the weights of the proprietary models.
So when it comes to data unlearning, only open weight models. When it comes to behavior unlearning, I mentioned earlier log props. Basically, we can also, for example, apply the same kind of techniques on models like Gemini that give you access not to the weights, of course, but to the log probabilities, or like the probability that the top next n tokens will be outputted by the model. Now, once we analyze how different behaviors are manifested, not just in the weights, but also on these probabilities or the patterns that appear in the top n tokens, we can apply, we call it right now internally a prism. It's not live yet, this feature, but basically what we found is we can develop an algorithm that re-ranks the top n tokens and their distribution to steer them all away from a biased direction, from a vulnerable direction, and so forth. One thing that I want to be very frank about, and maybe like, we talked about not being salesy. This is the opposite of being salesy, but in this sense, we do have a dependence on having access to log props. So right now, Google are offering this openly. OpenAI and Anthropic used to. It's a bit more limited now, but it does give us one layer beneath the output And that gives us an ability to change the outcomes in a deeper level than external solutions.
But most of the people using you right now are working with open weights. Is that fair?
Yes, but because that's because where we started from. It's a relatively new feature that we're working on that also required a lot of deep research. And B, we're working with a lot of enterprises that are working really on-prem. Sometimes for their internal models, enterprise knowledge bases, and so forth, right? And then like they're also reliant on open models. But I think like as we grow, obviously, we want to capture more of the market, and this Prism approach is pretty cool, both from the technical side, but also just like expands a whole new landscape for us for wider adoption.
So the other trendy thing this year obviously is agents, and with agents,
Yeah.
right? So you probably the common pattern these days is you have a big foundation model that kind of does a little bit of the coordination and orchestration, but then a bunch of small models that specialize, or which are specialist agents or remote tools that this bigger model calls. So how much do I need you if I'm actually just calling tools or I'm using smaller models?
Well, I think like I talked about bringing AI in enterprise to deployment rather than getting stuck in the hype and what we call the playground. I think like with agents, with full honesty, I think like we're still having a question mark, just like generally around will this fulfill the promise that we're seeing this year? But the main point that I want to bring is the fact that with agents, given that they work autonomously in usually things that are business critical, they're much more critical than a general chatbot, and also their chance of error compounds, right? And that's why we're seeing a lot of challenge with implementing agents end to end without a human in the loop, because even a 1% chance of error after enough iterations of the agents in a closed loop becomes a 20% chance of a mistake. And if you're talking about financial transaction, it's not a risk that you can bear. So for us, being able to reduce the chance of mistake or the risk of any problem that will arise in agents provides like an even bigger opportunity, right?
So the another trendy thing this year, more so than last year even, is AI for programming, software engineering, and coding. And I can imagine you folks would be useful there. One, IP protection, right? So both ways, right? So you don't want your developers to be using kind of code generated by these models that might be not ideal from an IP perspective. So am I right? So that are people using your tools also for models they use for coding and programming?
Yeah, so it's one of the areas that we're most excited about. I want to say it's not only about IP, but also, again, about if you have maybe outdated libraries that the model keeps referring to, maybe if you have, again, some malicious code that somehow found its way, especially, if you're using some fine-tuned open model from Hugging Face or something. All of these areas, again, like they're becoming more and more critical with a wider adoption of coding agents. And for us, like it's just very interesting to apply these techniques also to these very specialized models.
So looking ahead to the rest of 2026, right? So obviously, unlearning is not 100% solved problem. You talked about you still need to work on multi-modality, or
Yeah.
at least in the product, right? So what else is in your near-term roadmap in terms of your R&D, in terms of what do you need to get better in, and what are some things that you already have in the works but just haven't deployed yet?
Right. So I would say the general premise of things for me, it's also about becoming better in product. We're a very scientific company,
Yeah.
which is amazing and good, but also, I want to be killer on the product side, just to make it much more seamless, much more intuitive, and integrate across the wide ecosystem. I think like in these kind of things, in MLOps. You gotta be sticky, work with everyone, and integrate yourself into the workflows of the customer. So we have both like the platform as a web app and the Python SDK, fast API, but like at the end of the day, we need to be everywhere to become a critical component of every release cycle, and so forth. That's one. Two, you mentioned multimodal. I mentioned also the Prism for log props, saying that I'm, especially with the Prism, that's in the near future for us, something that I want to see in production. Yeah, and I think like for us, like the main task is to also make Unlearning like become the new standard in the industry. I would say being like the underdog from Israel right now, claiming that we solved something that Google, Microsoft, Meta, Amazon have tried to solve. It's a challenge and a lot of market education. But those are the things that I'm most excited about, just like being able to create a new standard and being a small part of this larger revolution.
So at this point, Ben, would you consider your tools and unlearning in general somewhat model agnostic in the following sense, right? So if next week AI Lab releases a model that's quite good, rockets up LM Arena, but in effect uses some sort of different architecture. I'm not saying it's not transformers, but a departure from what people are doing.
Yeah.
How quickly can you adjust to that?
So we've had the same thing like with Mamba or like Mamba hybrid models where we had a question mark of will it work out of the box?
Does anyone use moms?
I think some of the new models include some components of Mamba. There's like, we're Israeli, so AI 21,
Yeah.
we're known to be pioneers of implementing it. But I think like one of the models that we're now doing a case study on is Nemotron. And I think like one of the Nemotrons has the Nemotron Nano V2 or 3 have Mamba in it. But it's less about Mamba and more about can our technology adapt to a new architecture? And
Yeah.
it's not that we had to rebuild the product. It took us like a week or two to adapt the existing engine to work on Mamba, and it works successfully. Does it work on world models yet? I don't know to tell you, but at the end of the day, as long as you have neural networks with different weights that are represented and different vectors that are representative of different traits and knowledge and information of models, we're there, we'll support it. But we shouldn't freeze in time. Like the industry will continue to develop, we'll continue to develop. And I claim the best AI research team in Israel for a company our size. So we're up for the task.
So speaking of product, right? So as I mentioned, so one of the attractive things about things like guardrails, context engineering, RAG, those kinds of things, they're easy to explain in some ways. You might even be able to build user interfaces to guide, to show the the user what's happening, right? So for guardrails and things like that. So how do you engender trust? So what's the level of explainability or transparency in your platform to give comfort to the user that, okay, so this is headed in the right direction, or I kind of know what this thing is doing. It's not 100% a black box, even though the underlying model itself is a black box, but what Hirundo is doing, I can kind of understand.
Right. So a lot of what we do, as I said earlier, is explaining like you got to understand to some extent how things work within this model in order to solve these issues, right? So we're big believers in explainability. We just see explainability as the first step towards actionability. The next thing is what we've learned is two things. The evaluation component in our product is something that is going through a major upgrade because indeed we owe it to our users, especially given like the access that they're giving us, to explain every bit and piece that was impacted by our process, right? So to show them every benchmark that they care about, that they don't know maybe that they care about, even if there was 1% degradation in some capacity, which usually doesn't happen, but sometimes it does, to make sure that we put it in the front so they know when they take the decision on whether this model is production ready or not. That's one. Two, we're also introducing a measure of scale of how aggressive you want the process to be versus how moderate, right? We talked about a trade-off between utility preservation, all of the characteristics of the model that you actually want to keep intact, and the things that you want to mitigate or eliminate. And we're now in, as I said, like there's a delicate balance between predefined workflows and a lot of customization. But we want to give the user the control to say, like, I don't care about, let's say, coding capabilities for my chatbot. I just want to reduce bias to the bare minimum. So they can choose like that the aggressiveness of the process will be as strong as possible. But if it's an all-around model that serves many different purposes, maybe they want the middle ground where the utility is preserved all across the bench. And they see a reduction in bias, but not as powerful as they could have had if they would let go of coding capabilities, for example.
This may sound cheesy, but do you think it'll help to have some sort of visualization, kind of like a MRI? Where you kind of light up a little bit. Hey, this is when you're working on bias, you can see this is happening. I don't know. I mean,
Yeah,
because some of these some of the teams you will work with may not be that ML savvy, right? So they don't
yeah,
they don't understand the metrics and the eval terminology and things like that. You can have
right.
that, but in addition to have some sort of cheesy visualization. I don't know. What do you think?
That when you started asking the previous question,
Yeah.
that's the image that I also had in my mind. Like, right, we're talking about discovering the neurons that are
Yeah.
responsible for things.
Yeah.
Again, I think like we're going through a revamping of the entire like design of the product to make it much more intuitive and user friendly. And as I opened, like it's usually surprising to people that hear about the company or hear me talk about the company that I'm not technical. But I keep telling my team that like my dream is like for a user like me to be able to do these things end to end without being a trained data scientist, for example. I think like talking in this more simpler language, having easy visualizations is my favorite trait. So I like it. Will it be tomorrow morning in a product? I don't know, but it's definitely something that we try to optimize for, which is to make it more understandable for the layman.
Yeah, yeah, and engaging, right? So,
Yeah.
yeah, yeah. And with that, thank you, Ben.
Thank you, Ben.